This is a tutorial for my Convex Collider Creator Unity asset, available on the Unity Asset Store. You can find links to the store page and documentation in the description. In this tutorial, I'll be covering the features of the asset, including the editor window and collider group component. The first thing we need to do is open the collider editor window, which you can do by going up to Window and clicking on Convex Collider Creator, or just pressing Alt-C. And this is the window that you will use for editing colliders. The first thing we will look at is the Editor Options section of the window, which contains various options for customizing the way we preview colliders as we edit them. The first thing we can adjust here is the GUI width scale, which adjusts the width of UI elements inside of the window, and you can adjust that to your preference. And up here we have an option called Reload Window on Compile, which basically closes and reopens the editor window after code is compiled, because sometimes that can cause issues with the undo and redo states in the editor. However, the window will not remain docked if it was docked previously upon reopening. And next we have Mesh Preview Mode, which is basically how colliders will be previewed. And if I just select a game object here, we can see a preview up here. And right now it's set to Real Mesh, which means we get to basically see the actual mesh of the collider as we're editing it. And the next option is Box Approximation, which basically uses some gizmos to draw a rough approximation of the collider in a box shape. However, most of the time you're probably going to just want to stick with Real Mesh, and of course none just disables it entirely. And then the live preview option determines whether or not the collider updates as we edit it. And then Preview All Colliders basically allows us to draw wireframe previews for all colliders on an object when we're working with multiple colliders on a single object. And then Live Edit Update Time is the time interval in seconds between preview updates. Right now it's set to 0.2 seconds, and it's a little choppy. For the sake of this tutorial, I'm going to put it to 0 so it continuously updates. As we can see, it's much smoother now. Next, we will move on to the Target Object section to configure options related to the target game object. And the first option we have is Target is Selection, which just means that the target will be whichever game object we have selected. So you can see as the target object changes as we select different objects. And then Null Selection Clears Target just means that the target will be set to null if we deselect an object. Otherwise, it'll stay, active in the window, even when the object is not selected. And then Use Collider Group basically determines whether or not we're going to be using a collider group component in order to edit multiple colliders at a time. First, I'm going to start by clicking this button to create a collider group on the target object. And we can see the component here. Currently, there is no actual collider information on the object. As you can see, the colliders list is empty, which means that changes we make will be not tracked with undo states because there's no information being serialized on the object yet. The one we're editing here is just like the temporary preview one, which we can turn into an actual collider by choosing Generate Collider. And now the data is being saved, and we can undo and redo it as we please. You can also choose Create New to create new colliders on an object over here on the component. Furthermore, you can edit any collider on an object by clicking the Edit button on the collider component, and it will automatically open up the window and navigate to that collider as the active one for editing. And here you can see the wireframe preview for the non-active colliders here, as we talked about with the preview all colliders option. And we can see the box approximation works similarly. And when we have multiple colliders on an object, we can navigate through them here as well with the collider index. And then the maximum index basically indicates a brand new collider that can be added at the end of the list. Because first we have 0, 1, 2, 3 for the 3 that exist here in the list, and then the third one, the one at the 3 index, or the 4th collider on the object, does not yet exist, and we can add it by choosing Generate. And of course, we can delete colliders by clicking the delete button on any collider in the editor, or clicking it in the editor window over here. And it can be undone and redone. And you can duplicate colliders as well by clicking the duplicate button. And of course, you can rename them if you want to. And clicking the generate button here basically generates all colliders in the list on the object and creates corresponding mesh collider components for them. Next we have isTrigger, which basically determines whether or not the collider component is marked as a trigger. And then we have the physics material field, which is just the physics material for physics on the collider component. And then Polygon limit test, which is basically how the poly count of the mesh is tested in order to avoid errors due to having too many polygons, since the limit is 255. And we'll get back to that in a bit after I talk about the detail section down here. The next section I will talk about is the preset and mesh saving section, which basically lets you save to and load from presets for individual colliders, or save the actual mesh collider or collision mesh. And we can create a collider preset by going to Create in the project window and then choosing Convex Collider Creator and then Collider Preset. And now we have a collider preset asset right here, which contains the information associated with the collider. And in order to save to a preset or load from it, we have to link it first by dragging it into the field right here. And now settings can be saved to it as such. So now we've saved it and it's been saved in the asset. Or we can load from it, as I'll show in a moment. And now it goes right back to the way it was when we saved it. And next to that, we can save the generated mesh as an asset as well, if you want to use it for some other purpose. So when the path is just set to assets, we can choose Save Mesh or Save Mesh As, and it'll open up a dialog to save the mesh. And we can do that right here. I'll just leave it like that. And now we go to where we saved it in the folder, and we have the collider mesh right here. Actually, first we have to generate the collider before saving it. Because we only saved the preset, we did not actually generate the mesh yet. So I'll try saving it again. And now it should be updated, as we can see here. And of course, choosing Save Mesh As just changes the path that the mesh is saved to. And something else that's related to properties on the component over here is the Draw Default Inspector dropdown, which just basically exposes all of the associated collider properties in the group for perhaps debug purposes or something else. I would not suggest manipulating properties directly, but you can still see them here nonetheless. Next, I will move on to the corners section here. We'll come back to mirroring and flipping in a moment. So corners basically is the section all about how the corners of the box are positioned. And here in the positions section, you'll see how the corners are positioned. And you can hide or show position handles with this. And there are several modes for editing the position of corners on the collider. The first one is box center, which basically positions the corners based on a box extents or size field and then the offset or center position of the box, which you can adjust here. The handles here in the scene view allow you to adjust the size of the box like this, as well as move the center of the box. And if you have the object selected, try not to get it confused with the actual position handle for the game object itself. And I should mention that all positioning properties or rotation type properties that you see here are in the local space of the game object. The next mode for positioning corners is the box sides mode, which basically allows you to move the sides of the boxes directly as such. And you can see positive box side extents and negative box side extents here, which defines the extent of each side in local space. And you can switch back and forth between the center and side mode freely. And then the final mode is individual, which allows you to move each corner freely. And you can achieve many unique collider shapes with this. However, you should know that switching back to one of the box modes will revert the corners to the box shape and lose their individual positioning information. And the move tool has to be selected in order to move the corners. Next, I will move on to the corner radii, or the radius of each corner. As I've already shown earlier in the video, you can adjust the radius of corners by dragging these orange sphere handles right here. And you can hide or show the handles like this by clicking these checkboxes, or the gizmos. As you can see, there are these red circle gizmos kind of approximating the radius. And then there are several modes for editing radii as well. The first one is uniform, which basically forces all of the corner radii to be the same. And you can drag any of the handles to adjust them together. And then the next one is uniform individual, which allows you to adjust them individually. And you can also use the sliders here in the inspector. And then max radius basically indicates the maximum radius allowed while editing, for the sake of the upper limit on the sliders. Even though in most cases you're probably not going to need to make them larger than 1 or so. And then the final radius editing mode is advanced, which allows you to basically modify the individual components of the corners freely. As you can see here, the handles and gizmos change, and you can adjust the radius about each axis individually. And this is nice, for example, when you want to make, maybe one side flat, and then, but the other side's rounded like this, or you can kind of stretch it out like that, and get some interesting shapes. And now I'll move on to the radius offset section. And radius offsets basically can adjust how the center of each corner is offset based on the radius as it changes. For example, right now the radius offset for all corners is set to 1, which means that the positions of the corners are completely influenced by the radius as it changes. And this is for the sake of maintaining the dimensions of the collider as the radius changes. As you can see here, even when I make the radius bigger or smaller, the sides stay at the same place. However, if I reduce the radius offset to 0, the sides move instead and the center of each corner stays in the same place as the radius changes. And you probably want to keep it in the 0 to 1 range, because anything beyond that is just overcorrecting, since it's basically a form of linear interpolation. And you can also, adjust the maximal offset allowed right here. And much like the radii, you can also modify the radius offsets in a similar manner with the 3 different modes. And one thing I forgot to mention here is the radius handle mode, which determines whether you are modifying either the radii or radius offsets with the scene view handles. As you can see, I've switched to offsets in the scene view here, and the radius offsets is advanced, so we can adjust the offsets about each individual axis. Maybe we only want the corners to be offset on the XZ plane as the radius changes, as we can see here. Or rather, maintained on the XZ plane, since we reduced the offsets to 0 on the Y-axis for these top corners here. Since you can see how only the sides are staying in place now, while the top moves up and down. The next section we will look at is the collider detail section, which allows us to adjust the detail of the collider in several ways. The first option we see here is the corner detail, which refers to the 4 lateral corners, not the 8 individual corners we were just modifying. And you can adjust the detail of all of them here by dragging this slider, as you can see here. Or you can adjust them individually by switching the edit mode to individual, and each one now can be adjusted individually. Next is the top and bottom segments, which allow us to adjust the number of edge loops around the top and bottom sections, as you can see here. And when reducing it to 0 like this, reducing all the detail values to 0 makes a sort of, sharp box shape. When you do this, I recommend reducing the radius of the corners to 0 as well, as you can see here. Because when I adjust the corner positions, you can get this kind of vertex sticking out here, and that's just due to the nature of how the mesh is generated. But see, when you reduce it to 0, the problem disappears. And next we have XY, YZ, and XZ plane strips. These are basically the number of edge loops around each plane on the collider. And the letters here indicate the axes that are in the plane. So you see XY, so the plane that the edge loops are on the plane occupied by the X and Y axes, as you can see here. Same for YZ, these two. And XZ, which is the lateral plane. And then we have the detail smoothness option, which adjusts the smoothness of how intermittent vertices are interpolated, and is best observed when the mode is set to individual on positioning, and when the radii are different for each corner. And I'll increase the detail a little bit. It's most noticeable when you have more intermittent plane strips. And right now the smoothness is set to 1, so you have this nice curved shape right here. But when you reduce it to 0, the interpolation becomes completely linear. And then finally we have upper strip distribution and lower strip distribution, which basically just modifies how the top and bottom segment edge loops are distributed, in the curve here. Lower strip distribution basically affects the bottom strips or lower bound area, and then upper strip is like the top side. You usually just want to leave it at the default values. Now I will take a moment to go back up to the polygon limit test options and detail reduction options. And first I will disable that. I'll talk about that in a moment. And we're going to try to reach the polygon limit by increasing the detail drastically. And let's see what happens. Oh. So there's an error basically because we have reached the 255 polygon limit. And one way to deal with this is the automatic detail reduction here, which will automatically reduce the detail values until the collider falls within the appropriate limit. And we can start with all, which basically will cycle through each of these detail values, reducing them one at a time, sort of maintaining a proportional relationship between the values. As we can see here, when we choose generate, they will automatically reduce, like such. And the reason why we still got an error is because it must have reached the maximum number of attempts. Because with each attempt, it has to regenerate the collider and see if it has reached the limit or not. So we'll increase that a little bit. And okay. So it's not completely perfect. However, this gives me the opportunity to talk about the limit test mode. As you can see, I switched it to safe guess, and then it worked and reduced it appropriately. Also, the largest first mode basically starts by reducing the larger values initially, instead of all of them together. But anyways, the basic modes here that you see, best guess and safe guess basically choose between the last 4 modes here, based on certain parameters I'll talk about in a moment. Forced triangles mode basically counts the number of triangles in the mesh individually, and is the most safe estimate, but isn't terribly accurate because of how certain triangles are merged into coplanar polygons. Then forced quads is a little more accurate, but not completely safe because it assumes every pair of triangles is a quad. And then forced edge quads basically takes a more accurate but less safe estimate based on the edge and detail roundness. And then the face edge quads also takes the number of face subdivisions into account and is more safe because the previous edge quads mode does not take that into consideration. And you probably are going to want to stick with the best guess or safe guess in most cases. And from those two options, it'll choose one of these four based on whether or not the collider is in a simple box shape, which greatly reduces the amount of polygons in the resulting mesh. And what determines whether the collider is in a box shape is basically that the position edit mode be either box center or box sides, and the radii and radius offsets mode be set to uniform, both of them, because otherwise, now as you can see here, the edge is slanted and it's not, a smooth flat box shape, or rather the side is not completely flat like it would be on a box, and it adds more detail. And on top of that, the list of deform hooks must be 0, but I'm not ready to talk about that just yet. In the end, the whole reason that the detail or reduction and polygon limit test features exist is because there is no other way to really properly catch the error thrown by the physics engine itself upon generating the collision mesh. So I have to come up with these approximations, and they will generally work most of the time, especially if you choose safe guess. And the auto detail reduction is only really necessary if you're doing runtime collider generation, like while the game is running, and you set the detail to a certain preset, starting amount, and you just want it to automatically reduce itself to the appropriate level. But in most cases, you're probably just going to set the detail to the right level to begin with inside the editor. Now we are going to move on to the deform hooks, which allows us to fine-tune the shape of our collider with these sort of local space objects that deform the resulting mesh generated from the other properties. And I'll just increase the detail a bit. And as you can see here, we edit a hook by clicking the plus button here. You can also remove them with the minus button. And we can move it around and see how it deforms the mesh. Right now it's pulling out in this direction. And you can also rotate them. You can drag this to expand the radius of effect. And you can also increase the strength with this magenta handle right here. And then you can also adjust the fall off with the cyan handle. And how the fall off works is it's basically a power applied to the distance between the individual vertices and the hook origin. And keeping the fall off at 1 basically creates a linear fall off behavior, as you can see here. And you can see how the fall off affects the shape of the deformation here. As such. Of course, all these values can be modified in the inspector here. And there are 3 different types of hooks as well. The first one I've been showing here is the pull type, which just pulls vertices in the direction that it's pointing in local space. And you can negate it like this to push in the opposite direction. And note that the handle here scales the value of the fall off indicated by this gizmo here. And if you want to flip it around, you have to basically drag it in the opposite direction like that. And now I'll show you the twist handle. And what that does is it basically twists vertices to match the rotation of the hook in local space. And you can even use that to rotate colliders in local space, essentially. As you can see here. And then the last mode is expand, which allows you to basically expand or shrink vertices within the hook's radius. And you can kind of inflate a mesh like that. And you can hide and show various handles of the hooks as well with these options here to reduce the visual clutter. And you can change the name of hooks too. Oops. And you can add multiple hooks to an object, as many as you want. An important thing to note is that the deformations are applied from top to bottom in the list. So for example, I can stretch out the vertices on the front first like this, and then I can use the second hook here to then pull them up like that. And then I can generate the collider, select it, and we can see the collider right here. You can get a lot of interesting shapes like this. And you can enable or disable hooks with the checkbox here. And since this is a reorderable list, you can change the order of items in the list as well, and the order that the deformations are applied. Now to wrap up the window, I will talk about the mirroring and flipping options. And basically, how this works is, well, I mean, it's pretty self-explanatory. You know, the flipping buttons just flip colliders about the axis indicated on each button, as I'll show you here. If I move this up like this, and this bigger like that, oops. And then I can mirror flip the object in a local space, and it flips like that on the local x-axis. And you can flip it upside down or front to back, whatever you want. And then mirroring is different. Mirroring basically copies the information from one side and mirrors it to the opposite side. So we can do something like that, and now both sides are the same. And the plus and minus signs indicate which side of the axis is being copied to the opposite one. So for example, minus x, I can take everything from the negative x side and put it onto the positive x side, but mirrored, like that. And you can see the axes here up in the top right. Or you can mirror negative y to positive y, like that. And then we can do positive z to negative z, like that. And we effectively create a box shape. And one thing to note is how local space affects the flipping and mirroring. For example, I can move everything to the right of the origin of the object like this, and then I flip it. I can go switch the collider between each side like that. And that's useful, say, if you want to have the same collider on both sides of an object, but mirrored. I could just duplicate it, edit, and then flip. And now I have the same one on each side of the object. Basically mirror images of each other. However, if you push the mirror button on a collider, it basically mirrors everything here to the opposite side like that. So everything on this side of the collider is now on the very opposite side, and this part that was in the middle has been lost. Same thing, with the other axes as well. Mirroring negative y, now it's like that. Flipping x or mirroring x. And hooks are also mirrored and flipped in the same manner. So for example, we can add a hook here. Push out the vertices on this side a bit. And then we can just flip. Now it's on the opposite side. Can rotate it to point up a little bit. And we can flip it up and down like that. And mirroring will copy it to the opposite side like this. And then we can copy them to the back side as well. And actually, I clicked mirror negative z, so everything from the negative side was copied to the front, or the back to front. And as such, since there were no hooks on the back side, the ones on the front were removed. But we can undo that. And we can flip it like that, copy them to the back side, copy them to the bottom even. Or rather, since these ones are on the plane that is at the very center of the axis that are being mirrored, the hooks were not copied. However, if we move one of the hooks up a little bit, now it will be mirrored like that. I'll show you a simpler example. So we have a hook at the very center of the object. It's not going to be mirrored or copied to the opposite side because it's at the very middle of the object. It can still be flipped, but if you want it mirrored, we have to be slightly offset from the center, like that. And we can do the same on the other axes. And then at the very bottom, we also have some reset buttons. Reset box and corners basically just resets the colliders to have their corners be arranged in the default box shape. And then reset detail resets all the detail values to the default. And then reset hooks resets hooks to their defaults. Delete all hooks deletes all hooks. And then delete all colliders will delete all colliders on the object. And one last thing I want to cover is the collider group presets, which basically allow you to save presets for entire collider groups. So say we have a collider like this. Here we go. Have another one like this. And we have another one like this. So we have 3 colliders on the object that we want to save as a preset. So maybe we can use it on another object if we want. Well, first we have to create a preset to link to the collider group component. So we go up here to Convex Collider Creator and choose Collider Group preset, and which contains the information for a number of colliders. And we drag it over here to link it, and now we can save to the preset, and we can see our information is on the preset now. And now we can manipulate the colliders a bit. And this extra one here is just the temporary preview mesh for the last index that is not actually on the collider group. And then we can just click load from preset to revert it back to the way it was when we saved it. And one more option to cover on the collider group is the generate colliders on start, which basically just generates all the colliders in the start event on the game object. And this is useful when working with prefabs because generated procedural colliders are not saved to prefabs. And that's just a Unity thing. As you can see, they're gone. So now we can revert it to the prefab, but the mesh is not here. But we choose generate on start and enter play mode, and they will automatically appear. And we go back to scene view, and we can see the colliders are right here. No colliders, and now colliders. And I believe the window undocked itself because we switched to the game view. But that is essentially the gist of Convex Collider Creator on the Unity Asset Store. If you have any trouble with the asset or need any support at all, do not hesitate to contact me at justin@justinvoke.com with a valid invoice number from purchase, and I'll be happy to help. I may create more tutorials in the future for this asset, such as working with runtime collider generation, as in the example seen here, or setting up colliders for specific objects in the other example scene. But for now, you can just kind of inspect what is here, the scenes here included with the package. You can see the runtime example script right here. And then a number of example objects you can create colliders for in this scene. And you can see here just how intricate the colliders can be on these objects and what is possible with the asset. All of these objects are included with editable collider presets and prefabs. Unfortunately, the hook gizmos can be a little bit slow. Might try to work on that in the future. So yeah, thanks for watching, and I hope you enjoy using this asset. If you have any suggestions about usability or improvements, please let me know. And don't forget to check out the included PDF documentation for the script reference in case you work with procedural collider generation at runtime.